Welcome to clickmyproject.com. Now we discuss about the product for RegularRoute, an efficient detailed router applying regular routing patterns. Then we discuss about the abstract for the product. Placement is one of the visual steps in mapping a design into FPGA in order to take best advantage of the resources and flexibility providing by it. Because of its enormous computational complexity, VLSI routing is usually carried out through the consecutive global routing and the detailed routing stages. In the global routing stage, rough routing solutions are generated based on C-cell to G-cell process. Example for the global to global routing process. Then the detailed routing on the other hand realize the routing path honoring exact geometrical constraints based on the global routing solutions. Detailed routing is the important design stage in a sense that it's a critical for design rule satisfaction on the routing computation. In this paper, we propose a regular routing and efficient detailed router encouraging the regular routing patterns. Regular routing is the proposed for potentially better design rule satisfaction based on the corrected by construction methodology. Given the underlying the spacing based design rule, 2D global routing solutions and the 3D detailed routing tracks. RegularRoute generates the 3D detailed routing solution in a bottom-up layer-by-layer framework. At the beginning, local nets of the layer-by-layer process are routed using the vertical spine topology. Routing usage of the local net is treated as blocking when the assigning of global segments. Then each layer for formulate the problem of global segment assignment inside the each panel. Example for grounded routing track as the maximum weighted independent problems. We propose the fast and effective heuristic to solve the MWIS problems. We unsigned segments are partially routed by the greedy technique. For the unrouted portion of each segment, its terminals are promoted so that the assignment of deferred to the upper layers. At the top layer, we apply the panel merging and the mesh routing technique to improve the routability. RegularRoute generates the detailed routing solutions that satisfy the basic spacing based design rules. To satisfy all the design rules, we propose the abstract of idea of local optimization based on local shift and reroute assuming the most design rules of complex functions of local neighborhood geometrics. Because of unavailability of proper academic grade based detailed routing benchmarks, we propose the two set detailed routing of test cases derived from the any type of benchmark processings. Flow diagram for the product. First, initialize the points in due to the any type of benchmark circuit our RegularRoute wheel architecture process. Thus, the benchmark circuit to be read the initialize the points and to arrange the matrix formation our the next step. Then we calculate the extract the area fitness for based on the population initialization in our architecture process. Then the extract the area fitness points, then to apply the particle fitness. This is the particle fitness due to the if conditions based on matching fitness level. Thus the matching fitness level is to be no and yes process. The no process to be applied to relocate the particle fitness and the x conditions to update particle points. Thus the process to be continuously based on our overall particle points level in our architecture process. Then to update the particle level, that split out the our process, then to merge our the particle swarm optimization technique. This PSO optimization technique based on our the population initialization extract area fitness points in our architecture level. Thus the architecture to update the particles and to replace the particle placement for our the PSO conditions. Thus the design rule based on process to update the overall process and to update the particle level, then to calculate the particling points in our population initialization process. Thus the parameter analysis for our the wire length and the population and the iteration, then the delay time for our overall processing level. Thus the point to update the overall process, then to check the updation of population initialization in our overall process. For required selected benchmark circuits results. Next we see the output for the product. First we run the main function for our regularity process. Then to select the any type of benchmark circuit, these benchmark circuits are considered the what are the particle points based on our populations, then to connect the routing process for our the routing length. Just we select the and to vary the particle placement for our regular routing functions, then to move the optimized fitness points our regular routing architectures. This routing architecture based on our movements, it's the particle swarm optimization technique. These are the function results based on our the selected benchmark circuits. First we benchmark circuits is based on our the particle placement in our processing results, then to process the particle swarm optimization in any type of witness points to select our the architecture. This is our the comparison results architecture. First down FPGA placement using the PSO and the cost value, then the number of iteration, then the graph for wire length of each MNC circuits, then the wire length and the circuit placements level, then to calculate the delay time for overall selected benchmark circuit, then calculate the wire length for each our MCNC circuit based on the wire length minimization, our overall architecture process. This is our selected benchmark circuit results based on critical path, channel length and power of, then the circuit size and optimized size for the PSO optimization technique in overall architecture level.